Hello to all at the European Society for the Cognitive Sciences of Music and those watching online. My name is Shawnee Duncan, and this is a presentation on my research co-authored with Guido Walls on how syncopation and low frequencies in music impact our desire to move. I'll start by touching on the key concepts of our study: groove, syncopation, low frequencies, and electronic dance music. Just before that, as a brief intro, I just want to highlight that movement in response to music spans cultures, history, and lifetimes. Dance appears in almost every culture, and we have evidence of dancing going back as far as 9,000 years ago, even in the womb where we can respond to music, and this response can persist and develop through life. So our first key concept is groove, which can be defined in musicology as the persistent rhythmic quality that draws a listener in. And in psychology, which is our focus, as the pleasurable urge to move to music. Groove can be influenced by a number of musical features and personal traits. One we're particularly interested in is syncopation, which can be defined as the violation of rhythmic expectancy, or as absence of notes at strong metric locations and the presence of notes at weak metric locations. Research points to medium levels of syncopation producing the most groove, and this can be influenced by musical expertise and familiarity with the music. Another musical element that impacts groove is low frequency amplitude. Low frequencies are anything below 300 Hz and are interesting because they can be both heard and felt, which when applied to music can result in increased enjoyment and groove. We are also better at synchronizing our neural oscillations to rhythms conveyed by lower frequencies, and there is evidence that low frequencies can create feelings of power and confidence. Not only do low frequencies in music increase groove and rhythmic accuracy, but they are also positively associated with the intensity of our movements. A good example of this is in house music, a popular type of electronic dance music, characterized by a strong persistent quarter note bass drum. So electronic dance music is particularly interesting for studying groove, as electronic instruments can create more dynamic sound shaping and more precise rhythmic timing compared to non-electronic styles, which in turn can induce more body movement compared to other genres. So given all of this, what did we predict? We predicted that house music featuring higher levels of low frequency amplitude and syncopation in basslines would result in higher reported groove scores, especially from those who prefer energetic music and like dancing. We recruited 179 participants with ages ranging between 18 and 70. We used a fully factorial randomized 2x2 within subject design, creating 4 experimental conditions: high LFA, low LFA, high syncopation, and low syncopation. To avoid any ambiguity, we named the dependent variable the urge to move instead of groove, and this was reported on a 5-point scale. We also collected relevant data using Goldsmith's Musical Sophistication Index and their Dance Sophistication Index, and the short test of musical preferences. For our stimuli, we created 20 house-style music clips using a Roland TR-8S drum machine and Logic Pro X. These clips were made with high syncopation and high LFA. We then adjusted the basslines to create low syncopation and low LFA versions, resulting in 4 versions of each clip. Low syncopation was achieved by moving bass notes from strong to weak beats, and low LFA was achieved by applying a 200 Hz low frequency cut to the basslines. The house style authenticity of the clips was verified by musical experts, and we calculated syncopation levels using a Python application, SymPy. All clips are available on the Open Science Framework. The experiment was conducted online via Qualtrics. Participants completed demographic questions. Then following a listening device test, they listened to and rated each clip. They then completed questionnaires on music sophistication, dance sophistication, and music preferences. We assessed groove for each music clip by asking participants to rate their agreement with the following statements: "This music evokes the sensation of wanting to move some parts of my body." Our results showed a significant interaction between LFA and syncopation. Post-hoc tests revealed that when LFA is low, the presence of syncopation does not result in a significant difference. We also ran a correlational analysis which showed significant positive relationships between groove ratings for high LFA plus high syncopation and measures of urge to dance, body awareness, musical emotion, and a preference for energetic and rhythmic music. In conclusion, our study demonstrates that high LFA and syncopation in house music basslines increase the urge to dance, and that groove perception is linked to individual music and dance experiences and genre preferences. Our findings underscore the close connection between music and dance, highlighting how specific musical elements can influence our physical responses to music. Thank you for your time. It's been a pleasure to be part of ESCOM. If you'd like to read the paper in full, it's currently in preprint and will soon be available in an issue of Music Perception.